Hello everyone, so in this video, let us talk about a medium level problem from LeetCode. The problem name is remove duplicates from sorted list 2. So as you can see in the problem statement, you are given the head of a sorted linked list. As you can see here, this is a sorted linked list. You have to delete all nodes that have duplicate numbers. So like duplicate numbers you have to delete, and you are only leave with distinct numbers. So as you can see in the list, whatever are the duplicate numbers or more than duplicates, you have to just remove all those nodes, and only the nodes which are unique and distinct should be returned, leaving only numbers from the original list. The original list is returned. So this is the new list that you have to form from this list. Return the linked list sorted as well. So it should be sorted as well like this. So in simple terms, you are given, as you can see, a linked list: 1, 2, 3, 3, then 4, then 4, and then 5. And you have to just return a new linked list such that only the ones which are distant should be returned as a linked list like this. What can you do? So there can be multiple things. You just have to ensure that because it is sorted, every number should not have a duplicate. Now, for a duplicate, you can check with the next number, that if it already like exists as a next number, then that is a duplicate number. So you should not take that inside the final output. But what you can see here is that if you take for every number, check it with the next number. Like, is this occurring again in the next, because it is sorted. So because it is sorted, if it is like occurring again, it is a bad thing. It is duplicate. So it is not occurring. So it is a fine. I will take this as a new uh, a node in the new linked list. Now two, check it with the next one. It is again not occurring, so I will put it in the new one, new linked list. Then as you can see here, that now I'll move to 3. Now 3 is occurring to the next one, so that is a duplicate, so we will not take it. So we'll move to the next one. Now as you can see again, 3, if you check it to the next one, you will assume that this 3 is not duplicate, but it is also duplicate. So which means that instead of checking with the next one, why not also check with the previous one as well? So for every node, you can check it with the next one and previous one. Okay. So if this node is unique, then it should not be occurring both on the left and right side. If it is not occurring both on the left and right side, that means that it is a unique number. So for that, now you will again iterate over the whole list, check with the left and right thing. So you have to maintain 3 pointers, 1, 2, 3, and you will just check that whether every number occurs on the left or right. If it occurs on the left or right, then don't put it inside a new list that you are forming. If it doesn't occur, then just keep on putting it inside a new list and you will get the answer. That's the complete logic that I have used here. There can be multiple more approaches. You can optimize it to 2 pointers. You can move, like do it in the same linked list as well. But nothing has mentioned been here. So I will make another video if everyone wants to be a more optimized version. But I think so that is more sufficient here. So let's go to the code part now. So let's bring down the code part. So what we have done here is that this is a so what we have to do is that we have to first make a new linked list that we'll make from here. So it is initialized with a node of -1 so that we can attach new nodes on top of it. Then this is, as you can see, a copy of this new linked list so that this linked list will move along by adding. So we will keep on adding on this new linked list, but we have to return the head. So we have to somehow store the head copy. This is the previous and the next of the current, you can say, linked list that we have to iterate over. So we have the head, the previous, and the next. The previous is initially null, the next is the head next, and the current is head. So what we're trying to do here is that we will iterate over the head until it is not empty. What we'll do is that if the previous doesn't exist, then it is fine. If it exists, and if its value is equal to the head value, so if it exists, so if a head value, if the previous exists, as you can see, let's say I'm here, if the previous exists and its value is equal to the head value, then which means that it is a duplicate. So we don't have to do anything. We'll move our head to the next, move our next to the next head next, and just move forward. So we are just iterating over and making all our next to the next values. That is fine. If the previous matches, then don't do it. If the next matches, then also don't do it. We'll just continue out. If both of them doesn't match, which means that that's a unique value. So now we will push that particular unique value inside a new list that we are forming and just move our new list to the next pointer so that we will keep on adding in the new list. So that is how you will add in the new list, and you will keep on adding to the next value. So you can put it here as well. So this value is also used to move, this also used to move, this is also used to move for this value. Okay, so this will somehow, that when you're adding the new value, you have to somehow go to the next value. So that is how you will move to the next value. And as you can see, if the head doesn't exist, then it is fine. If the head doesn't exist, then you have to make your next equal to head dot next. That is fine. So what we are trying to do is that we have to also move our next value, because as you can see that after this, we have to move our head pointer as well. So that is used to move our head pointer. Okay, and then in the end we have to return the new linked list that we have formed. So the new linked list is head.copy. That's why we have created this head copy, because new list has been moving along, as you can see here, to add new nodes in the new list that we are forming. So the head is the copy of the, you can say head copy is this new list copy. So we'll return this head dot next. Why? Because the first one is just a dummy node. We don't care about that particular node. The next, all of those are the actual list. This is just used to add a dummy node, so that on that particular node we'll keep on appending all these nodes. So what I'm trying to say here is that we have to make a new node, new linked list. Now a new linked list can be only appended to a node. So let's say this is some dummy node, that -1 1 2. So we are getting new nodes from the original. These nodes are get from the original node, the original linked list. So that is 1 and 2 and 5. So these are from the original node. We have to add it, but the node should be added on a particular dummy node, so that we will keep on adding. And in the end, this is the head copy that we are pointing to, but this is not the answer. The answer is this. This is the actual linked list. So we have to move and return head dot next to get the final output. So that's the complete logic and the code part for this particular problem. The problem is pretty much simple. We are just doing a for loop. So it is just, you can say, O of n time complexity. And then we are just using constant spaces for storing out these pointers, and nothing much complicated here itself. Even if you try to optimize it, then it is also fine. But the space or the time obviously doesn't change. Okay, you will optimize the process by like reducing one pointer, or like you can reduce it by like doing some space complexity analysis. But the overall idea is that these are just constant like values. So even the time complexity or space complexity doesn't, the space complexity doesn't change much. It's just a very small thing that it might change. That's the overall logic and the code part for this problem. But if you still want to optimize, reach out to me. I will be happy to help you out. Thank you for watching this video till the end. I will see you in the next one. Till coding, and bye.